Good morning, students. लास्ट लेक्चर में हम लोगों ने गियर ट्रेन्स में डिस्कशन किया था। सिंपल गियर ट्रेन और कंपाउंड गियर ट्रेन की वेलोसिटी रेशियोज और ट्रेन वैल्यूज को हम लोगों ने डिटरमाइन किया और उस पर बेस्ड न्यूमेरिकल सॉल्व किए थे। टुडेज टॉपिक इज रिवर्टेड गियर ट्रेन एंड एपिसाइक्लिक गियर ट्रेन। स्टार्ट करते हैं आज का टॉपिक। रिवर्टेड गियर ट्रेन। Reverted gear train when the axis of the driver and driven shaft are coaxial. It means जब ड्राइवर शाफ्ट और ड्रिवन शाफ्ट ड्राइवर गियर एंड ड्रिवन गियर्स की शाफ्ट एक लाइन में हो, कोएक्शियल हो, and the compound gear train is known as reverted gear train, and this type of gear train is known as reverted gear train when the driver and driven gear are shafts are coaxial. इस डायग्राम में गियर 1 shaft of gear 1 is coaxial with the shaft of gear 4. Okay, here gear 4 is the driven gear and gear 1 is the driver gear. Okay, it should be noted that the gears 1 and 4 are on the driver and driven shaft whose axes are collinear. The gear 2 and 3 are connected on the intermediate shaft. Here, gear 2 and 3 are mounted on same shaft, and these gears are intermediate gears. In the reverted gear train, the gear train can be only reverted if the sum of the pitch radius of gear 1 and 2 equals to the sum of pitch radius of gear 3 and gear 4. So, reverted gear train can only be possible when sum of pitch circle radius of gear 1 and 2 is equal to the pitch circle radius of gear 3 and 4. If R1 is the pitch circle radius of gear 1, pitch circle radius of gear 1, R2 is equal to the pitch circle radius of gear 2, and R3 is equal to the pitch circle radius of gear 3, and R4 is equal to the pitch circle radius of gear 4. Hence, reverted gear train can only be exist if sum of pitch circle radius of gear 1 and 2 is equal to the pitch circle radius of gear 3 and 4. Okay. let let n1 is equal to the speed of gear 1 and 2 is equal to the speed of gear 2 and 3 is equal to the speed of gear 3 and n4 is equal to the speed of gear 4 and T1 is equal to the number of teeth of gear 1. T2 is equal to the number of teeth of gear 2. T3 is equal to the number of teeth of gear 3 and T4 is equal to the number of teeth of gear 4. Okay, the gear 1 is mounted on the driver shaft and whereas gear 4 is mounted on driven shaft. Gear 2 and 3 are the intermediate gear. So as we know that the radius, pitch circle radius, sum of pitch circle radius of gear 1 and 2 is equal to the pitch circle radius of gear 3 and 4 for for a reverted gear train. If the circular pitch of all the gears is assumed to be same, if the circular pitch is same, then number of teeth on each wheel will be proportional to its circumference on radius or radius. Hence, if circular pitch is same, pitch of all gears are same, then number of teeth is proportional to the pitch circle radius. Then T1 plus T2 will be equal to the T3 plus T4. Suppose this is equation 1, this is the equation number 2. Okay. Now the speed ratio for gear 1 and 2. Speed ratio for gear 1 and gear 2 will be is equal to N1 upon N2 will be equal to the T2 upon T1. Equation number 3 and speed ratio for gear 3 and gear 4 will be N3 by N4 will be equal to the T4 by T3. Equation number 4. Now multiplying the equation 3 and 4, N1 upon N2 into N3 upon N4 equals to the T2 into T4 divided by T1 into T3. Here gear 1 and gear 2 and gear 3 are mounted on same shaft because gear 3 and gear 2 are mounted on same shaft. So N2 will be equal to the N3, speed of gear 2 will be equal to the speed of gear 3, then N1 upon N2 into N3 by N4, N3 can be replaced by N2 equal to T2 into T4 divided by T1 into 3, T3. Now N1 upon N4 will be equal to the T2 into T4 divided by T1 into T3. Here speed of driver gear, the ratio of speed of driver gear to the speed of driven gear is equal to the number of teeth of gear 2 into number of teeth of gear 4 divided by T1 into T3. If the gear 1 is rotates in clockwise direction, hence gear 2 will rotates in anti-clockwise direction. Gear 1 is meshes with the gear 2. Gear 1 is meshes with gear 2. If the gear 2 is rotating in counterclockwise direction, then gear 2 and gear 3 are on same shaft, then in that case gear 3 also rotates in counterclockwise direction. If the gear 3 is rotating in counterclockwise direction, then gear 3 is meshes with the gear 4, hence the gear 4 will rotates in clockwise direction. Okay. The numericals on reverted gear train is same as in compound gear train. Okay. Now discuss then now we will discuss on epicyclic gear trains. What is epicyclic gear train? Cyclic gear train. In epicyclic gear train, if the axis of the shafts over which the gear is mounted are moving related to a fixed axis, The gear no train is known as epicyclic gear train. Here, gear A is mounted on the shaft O1. Gear A is mounted on a shaft whose center of rotation is O1, and gear B is mounted on a shaft whose center of rotation is O2. O1 and O2 are attached with a arm, and in this type of gear train, if gear A is rotates about its center, then gear B rotates about its center also about the point O2, and gear B will rotates along the circumference of the gear A by the arm C also. So this type of gear train is known as epicyclic gear train. In epicyclic gear train, at least one of the gear axis is in motion related to the frame. Here, gear A and B, which are mashing with each other along with an arm, the arm and gear A are having common axis at O1 about which they can rotate. So gear A and arm C can rotate about a common axis passing from the point O1. The gear B is having its axis of rotation axis at O2 on the arm. If the arm is fixed, if O1 O2 is fixed, in that case the axis of the two shafts on which wheel A and B are mounted will be fixed, and we will get a simple gear train. If O1 O2 arm is fixed, in that case gear A and B makes a simple gear train. Hence a gear A can drive gear B or vice versa. But if the wheel A is fixed and arm is rotated about O1, then the gear B will be rotating about the gear A. If gear A is fixed and arm is rotating about the point O1, axis O1, in that case, gear B will be rotating about the gear A. Okay, and we get an epicyclic gear train. So this type of gear train is known as epicyclic gear trains. In this case, the gear B rolls about the gear A. Okay, whenever the axis or shaft of a gear rotates about the another gear, so this type of gear train is known as epicyclic gear train. Now the velocity ratio of the epicyclic gear train may be determined by various methods. First method to determine the velocity ratio is algebraic method, or relative velocity method. Second method is tabular method. We can determine the velocity ratio of any epicyclic gear train by two methods. First is algebraic or relative velocity method, and second is tabular method. Now, how can be how can the velocity ratio of epicyclic gear train calculated by the algebraic method? Algebraic method or relative velocity method. Let us consider a epicyclic gear train and two gears A and B and an arm C. Okay. In the algebraic method, the motion of each element of the epicyclic gear train relative to the arm is written in the form of an equation. First of all, for determining the velocity ratio of the epicyclic gear train by algebraic method, we have to write the equation for the each gear, the motion of which element of the epicyclic gear train related to the arm. Okay. Now the number of equations will be equal to the number of elements in the gear train. The fixed element will have zero speed. Other element has a specified or given speed. These two conditions are used for solving all the equations. Okay. Let NA equals to speed of gear A in RPM and B is equal to the speed of gear B in RPM and C is equal to the speed of arm C in RPM and TA is equal to the number of teeth on gear A and TB is equal to the number of teeth on gear B. The speed of gear A related to C. First, the speed of gear A relative to arm C will be equal to the speed of gear A minus speed of arm. Okay. And the speed of gear B relative to arm C will be equal to the speed of gear B minus speed of arm. Since the gears A and B are meshing directly, therefore they will revolve in opposite directions. Since the gears A and B meshes directly are meshing directly, therefore they will revolve in opposite directions. But the relative motion between a part of mating gears is always same, whether the axis of rotation are fixed or moving. And this ratio of relative motion is equal to the inverse ratio of the number of teeth on the gears. Therefore mating gears A and B have speed ratio speed of B relative to arm divided by speed of gear A relative to arm is equal to the minus number of teeth of gear A divided by number of teeth on gear B. Here minus sign will show that gear A rotates in opposite direction of gear B. So relative velocity, relative speed of gear B with respect to arm is NB minus NC, and speed of gear A relative to the arm C will be equal to NA minus NC. This will be equal to the TA minus TA upon TB, equation number 1. Since wheel A is fixed, since gear A or wheel A is fixed, hence NA will be equal to 0. Then from the above equation, NB minus NC from 0 minus NC is equal to minus TA upon TB, or NB upon NC plus 1 is equal to minus TA upon TB. For NB upon NC will be equal to the 1 plus TA upon TB, or speed of gear B will be equal to the speed of arm C in the bracket 1 plus TA upon TB. Hence, if the speed of arm C is known, then speed of wheel B can be calculated. The number of teeth on gears A and B are already given. Okay. Instead of gear A, the arm C is fixed. If arm C is fixed, then the ratio of the speed of gear B to the speed of gear A is obtained from the equation 1. NC will be equal to 0. Then NB minus 0 upon NA minus 0 equals to the minus TA upon TB, or say NB upon NA equals to the minus Ta upon Tb. The above equations shows that when the arm is fixed, the gear train becomes a simple gear train. Now the algebraic method is simple and easy of follow and hence mostly used for solving problems on epicyclic gear train. Now the arm of an epicyclic gear train rotates at 100 rpm in anti-clockwise direction. The arm carries two wheels A and B having 36 and 45 teeth respectively. The wheel A is fixed and the arm rotates about the center of wheel A. Now, what will be the speed of B if the wheel A instead of being fixed makes 200 rpm clockwise. Okay, the arm of an epicyclic gear train rotates at 100 rpm The arm of an epicyclic gear train rotates at 100 rpm in clockwise direction. The arm carries two wheels A and B having 36 and 45 teeth respectively. The wheel A is fixed and the arm rotated about the center of wheel A. What will be the speed of B if the wheel A, instead of being fixed, makes 200 rpm clockwise? This is the gear A, gear B, and arm C. Okay, given arm speed NC will be equal to the 100 rpm counterclockwise. Okay, anti-clockwise rotation is taken positive, whereas clockwise direction is negative. Anti-clockwise rotation is taken positive, whereas number of teeth on wheel A is 36 and number of teeth on wheel B is given 45. Uh, First case, when wheel A is fixed, hence hence speed of gear A is equal to 0. Second, when wheel A makes 200 rpm in clockwise, now first The speed of wheel A the speed of wheel A the speed of wheel A related to the arm C will be is equal to Na minus Nc, and the speed of wheel B related to the arm C will be is equal to the speed of wheel B minus speed of arm C. Since the wheels A and B are mashing directly, therefore they will revolve in opposite direction. But the relative motion between a pair of matting gears is always same whether the axis of rotation are fixed and this ratio of relative motion is equal to the inverse ratio of number of teeth on gears. Hence, for matting gears A and B, NB minus NC upon Na minus Nc will be equal to the minus Ta upon Tb. Okay, if Na is equal to 0, in that case Na equal to 0 and Nc is equal to 100 rpm, then Nb plus 100 upon 0 minus 100, not plus, minus, equals to the minus 36 upon 45, because number of teeth on gear A is 36 and number of teeth on gear B is 45. In that case, speed of the gear B will be 80 rpm. Here plus sign shows that the gear B will rotate in counterclockwise direction. Okay, and for second case, when gear A rotates in clockwise direction with 200 rpm and arm C rotates in counterclockwise direction with 100 rpm, then the speed of gear B will be Nb minus 100 upon minus 200 minus 100 is equal to the minus 36 by 45. Nb minus 100 is equal to the 300 into 4 by 5. So Nb minus 100 is equal to the 240. So the speed of gear B will be equal to 240 plus 100. It will be equal to the 340 rpm. Here the rotations of the gear B is positive, then the rotation of the gear B will be in counterclockwise direction. Okay, thank you very much.